Good morning and welcome to this presentation on the slump test experiment that was done by civil engineering students second year. This is group 4 that did the experiment, and we are presenting the report. The names and the registration numbers of all those who participated in compiling of the report are as shown in the slide 1. The table of contents: introduction, apparatus, material computation, the procedure that was used, the results discussion, the conclusion, and reference. Introduction: slump test is carried out to determine the workability of freshly mixed concrete. Workability of fresh concrete is the ability to work with fresh concrete, that is the ability to transport, place the concrete, compact the concrete, and finishing to the concrete. Workability of fresh concrete is determined by measuring the water-cement ratio of the concrete. The apparatus that were used are slump cone, that is 30 centimeters high, 20 centimeters and 10 centimeters diameter. The 10 centimeter diameter is at the top and 20 centimeter diameter at the bottom. A horizontal base plate, a tamping rod, a concrete mixer, a trowel, a weighing machine, a tape measure. The apparatus are as shown in the pictures in the slide. The materials that were used were cement, aggregates, and water. The aggregates used were fine aggregates and coarse aggregates. The material calculation: the volume of the cube was taken by 0.15 by 0.15 by 0.15 with a density of 2,400 kilograms per meter cubed. The mass was 8.1 kilograms. The volume of the cylinder was 0.00157 meters cubed. The density was 2,400 kilograms per meter cubed, and the mass was 3.77 kilograms. And 6 cylinders were made, so that was 22.26 kg. The volume of the beam was 0.53 by 0.15 by 0.15. The density was 2,400 kilograms per meter cubed. The mass was 28.62 kg for one beam. So 3 beams were made. That was a total of 85.86 kilograms. The total mass was 22.62 plus 85.68 plus 48.6, which gives you 157.08 kilograms. The ratio that was used of class 25 cement was 1:1.5:3. The cement used was 28.56 kg. We used sand of 42.84 kg, aggregate of 85.68 kg, and water at 14.28 kg. The procedure that was used: ensure all apparatus are clean, measure the material contents with a weighing machine, and pour to the concrete mix till the material mix is a homogeneous color. Oil the slump cone with a thin film to avoid sticking of concrete to the slump cone. Place the slump cone centrally on the plate with a small opening of the slump cone facing upward. Fill the slump cone with concrete in 3 layers, each layer tampered 25 times using a tamping rod. Top up the cone till it overflows. Level off the surface with a steel float. Clean off the base plate from any concrete excess. The cone is slowly raised vertically by the handles and allowed to fall. Turn the cone upside down and place the rod across the upturned cone. The slump is measured by using a tape measure, whereby the difference in level between the height of the cone and that of the height of the highest point of the subside concrete, and record the findings. The pictures on the slide show the mixing of the concrete, the slump cone being filled, and the slump measurements that was taken by the students in the laboratory. The results that were achieved: the initial record was 42 centimeters and the final record was 81 centimeters. The slump was 39 centimeters by subtracting the final record from the initial record. The results discussion. There are 4 types of slumps: a true slump, a zero slump, a collapse slump, and a shear slump. A zero slump, the amount of slump is 0. This means that the mix has very low water-cement ratio, therefore the mix is dry. A true slump, the amount of slump is to be measured. This means the mix has adequate water-cement ratio in the mix. A shear slump, one side of the slump is collapsed. This means the slump was not uniformly mixed. The mix is remixed and the slump test is carried out again. A collapsed slump, the slump value is very high. This means that the water-cement ratio is high, making the mix too wet. This type of concrete is not appropriate for slump test and concrete is to be retested. The table below shows the workability of concrete from different measurements of slump. To have a very low workability, the slump is from 0 to 25 centimeters, and such concrete is used on roads vibrated by power-operated machines. Having a low workability, the slump will give you 25 to 50 centimeters. The type of concrete is used in roads vibrated by hand-operated machines. To have a medium workability of concrete, the slump will give you 50 to 100 centimeters of slump. Such concrete is used in manually compacted slabs using crushed aggregates. To have a very high workability, the slump will give you 100 to 175 centimeters. Such concrete is used in sections with congested reinforcement. The conclusion from the experiment: slump test is carried out to measure the consistency of concrete before it sets. The ratio of class 25, which is 1:1.5:3, representing cement, fine aggregate, and coarse aggregate respectively. While there are different types of slumps, we got the true slump with the value of 39. Factors like time and wastage of cement affected the slump results, but according to our results, the slump practical test was successfully done. The references that were used during the experiment was a civil engineering materials handout that was given by the lecturer and the concrete mix design table 5.1. Thank you. Thank you for listening to the presentation.